Welcome to College Algebra, and specifically to Section 1.1. We will begin this course by having a quick review of linear equations. One of the most important things you should take away from college algebra is the vocabulary that we use. Oftentimes students have a difficult time simply because they don't understand the question because of some vocabulary. So our first fill in the blank says a number that makes an equation a true statement is called and there are a number of words we could use here that would be correct. We're going to start with a couple of them. The first one we'll talk about is we could use the word solution, or we could also call it a root of the equation. We're going to add some more vocabulary words that mean the same as these as we move through the course. Now, if we have more than one solution, we would have a set. And the set of all numbers that satisfy an equation is called the solution set of the equation. And we would use set notation to express that when there's more than one solution. And if we have two equations that have the same solution, but the equations are not necessarily identical, they would be called equivalent equations. And of course, equivalent is simply another word that is very similar to the word equal. Now, there are properties that we use in algebra, and I know these are very familiar. The cardinal rule in algebra is what thou doest to one side of the equation, doest also to the other. So if we were to add something to one side of an equation, as long as we add the same thing to the other side, we are not violating any rules in algebra. That's perfectly legal. It keeps things balanced. Same is true with multiplication. As long as we multiply or divide one side of the equation by a number, as long as we do the same to the other, then we are going to have an equivalent equation. Now, the one thing we do have to watch for, if we tried to divide each side or multiply each side of an equation by 0, that has a special property, because if I multiply anything times 0, I'm going to get 0 regardless of what I started with, and I can't divide any number by 0. That is a meaningless expression. So we have to make sure we don't use 0 when we're multiplying or dividing, but any other number will work. So let's move to the next page, and we will talk about how to solve a linear equation. First of all, to recognize that an equation is linear, that would mean if it were graphed, it would look like a line. As far as looking at the equation, the characteristics that we would notice, we have standard form of a linear equation written for us here. It's ax plus b equals 0. X is our variable, a and b stand for real numbers. And basically, as long as we do not see an exponent on our variable, the exponent is understood to be 1 when we don't see it. If the variable is not in the denominator, and if I do not see any special symbols like square roots around the variable, or absolute value, or any of the other special symbols we might have, then I should have a linear equation. So those are some characteristics we would look for in the equation. And as long as it's linear, we would typically have one value that most of the time when we solve we'll get. We're going to talk about what that's called when you get one value for an equation in a little bit, but first let's just practice solving to see if we can discover what value of x would be a solution or would make it true. Now notice in this example we have numbers on the left side in front of the parentheses. We have the number -4. On the right side we have a subtraction sign in front of a parentheses, and if you look at the box, it reminds us to use the distributive property when a number or a negative sign appears immediately in front of a parentheses. So to make sure that we use the distributive property correctly, that means we need to remember that everything inside the parentheses gets multiplied by that number that's in front. So if I multiply 3x minus 5 that's in the parentheses times the negative 4, I would have negative 12x, because negative 4 times 3x would be negative 12x, and negative 4 times negative 5 gives me a positive 20. Notice you're going to need to be confident with sign rules. You need to know how to add, subtract, multiply, and divide correctly with both positives and negatives. If you need some help with that, let me know, and I will try to give you some additional tutorial in that area. If we look at the right side of the equal sign, it starts off with just the number 3, and then we have that subtraction sign in front of the parentheses. Now you can think of this either as subtracting everything that's in the parentheses, which really means the same as adding the opposite of everything in the parentheses, or you could think of it as if there was a 1 squeezed in between the negative sign and the parentheses, and I'm multiplying everything inside by a negative 1. Whichever works better for you. Think of it that way. But that's going to mean, after this 3, negative 1 times 8x gives me a negative 8x. And negative 1 times 7 gives me a negative 7. I now have eliminated the parentheses, and it's time to combine like terms. Remember that numbers, real numbers, would only be able to be added or subtracted with other real numbers. If I have a term that has a variable, it can only be added or subtracted to another term that contains that same variable. So when I look on the right side, because I want to see if anything can be combined on the same side of the equal sign before I try to move anything to the other side, I see I have a positive 3 and I have a negative 7 on the same side. I could think of that minus 7 as plus a negative 7. So I'm adding positive 3 and negative 7. When I do that, that's going to give me a negative 4, and then I still have the minus 8x. All I have done is combined like terms on the right. There are no like terms on the left because one of the terms has the variable x and the other one does not. Now I need to get terms together on the same side. My recommendation is, since I have an x term on each side of the equal sign, look for the one that is smallest in value. Which one would be furthest to the left of 0 if I were thinking of looking at a number line? Because they're both negative numbers, negative 12 would be further to the left than negative 8. So negative 12x is smaller than negative 8x. What I want to do is add 12x to both sides. Remember, what I do to one side of an equation, I have to do the same to the other. So as long as I'm adding 12x to both sides, that makes my x terms cancel on the left, leaving just 20. On the right, I have negative 4, and then if I add negative 8x plus 12x, that gives me a positive 4x. All right, my goal is to isolate the x and get it by itself. So I'm going to leave the x term on the right side. The plus 4x is going to stay on the right, but I need to get rid of the negative 4 that's on the right. So in order to eliminate it from the right side, I would want to add 4 to each side. By doing that, it will cause the negative 4 plus 4 to cancel on the right. I now have 24 on the left equals 4x on the right. We're very close to solving for x. In order to get the x isolated, to get the x by itself, it has a 4 in front of it. Remember, if it's right in front of the variable, it means they're being multiplied together. It means 4 times x. What undoes multiplication? Division does. So if I divide both sides by 4, I now have my solution, x equals 6. If I were to go back to the original equation, I could put 6 in place of x, and when I clean everything up, I would see the left side of the equation is the same number as what's on the right side. And you are welcome to go back and check that to see that it really does work. Now, the next example has fractions. And I know many of you are uncomfortable with fractions, but there is a nice tool that if you know this, you can eliminate those fractions in the first step. Now listen carefully, it only works if you have an equation. If there is not an equal sign, I cannot eliminate fractions. But as long as there is an equal sign, the steps I will go through appear here in this box. If fractions appear in the equation, eliminate the fractions by first finding the LCD, the least common denominator, and then we're going to multiply every term by the LCD, even ones that didn't have fractions. Now all of these have a fraction, but if I had a whole number in there, it would still be multiplied by the LCD. So let's determine what the LCD is. If we look at our denominators, there's a 10, a 2, a 5, and a 5. I'm looking for the smallest number that 10, 2, and 5 would all divide into evenly. The answer must be 10. So if that's my LCD, I want to multiply every single term by 10. So I'm going to make a little space and recopy this problem. And once I have some room, each individual term is going to be multiplied by 10. And since we're working with fractions, if you want to write it as 10 over 1, feel free to do that. And what we will do now is multiply these together and reduce down. It's actually easier to reduce before you multiply. So as long as I chose my LCD wisely, if I got the correct LCD, what should happen is my denominator will cancel out in every single fraction. Look at the first one. I have a 10 in the denominator and a 10 in the numerator. Remember, if I'm multiplying fractions and I get a common factor between a numerator and a denominator, I can reduce down. So these 10s will cancel, and if I multiply that back together now, I just have 3x plus 6. No fraction. If I look at the next fraction, I have a 2 in the denominator and a 10 in the numerator. Well, 2 would go into both of those evenly. 2 goes into 2 one time, 2 goes into 10 5 times. And now if I multiply back through, I would have negative 5x. I would have the minus sign times 1 times x times 5. That's going to give me minus 5x. My left side is finished. No fractions. Look at the right. My first fractions that are being multiplied together, I have a 5 in the denominator, 10 in the numerator. 5 is the common factor, so it goes into 5 once, goes into 10 twice. Now if I multiply straight across, 2x times 2 is 4x. Plus, in the second fraction, 5 is the common factor again. And when I multiply that together, I get 66. 33 times 2 is 66. And voila, no more fractions. We're at the same point we were after we got rid of parentheses in the problem above. So from here, it should be a piece of cake. Remember, look to see if we have common like terms that we could combine. I do on the left side. I have a positive 3x and a negative 5x. When I add those together, I get negative 2x plus 6 equals, I still have 4x plus 66 on the right. Now I need to get the x terms together. Remember, look for the one that's smaller. Negative 2x is smaller than positive 4x, so let's add 2x to each side. That means I now have 6 equals 6x plus 66. Remember, I'm trying to get the x isolated, and the x term is on the right, so I need to get rid of the plus 66. I'll do that by subtracting 66 from each side. That means now, on the left, 6 minus 66 gives me negative 60 equals 6x. And the last step to solve for x would be to divide each side by 6, which means x equals negative 10. And that would be my solution. If I go back and I put negative 10 in place of x, I would discover that the left side of the equation will indeed equal the right side. Now, as we move to the left, we're going to put some names with types of equations we could see. So far, we have looked only at what's called a conditional equation. When we solved for x, we came up with one value. And as long as x is equal to that value, that's a solution. The left side would equal the right. But there are times that when we solve, our variable actually disappears. And if our variable disappears, it means we have one of two events that have occurred. It is either an identity or it will be a contradiction. So let's work through these so you can see the difference. And we'll try to put all this together, and we'll be through with section 1.1. Now, A is very much like the ones we just did, except it's even simpler. All I need to do is get my x's together. I don't need the distributive property, and I have no fractions to eliminate. 4x is smaller than 6x, so let's subtract 4x from each side. That means I now have 2x minus 9 on the left equals 13 on the right. To isolate the x term, I would need to add 9 to each side. That will leave me 2x on the left. The right side is 13 plus 9. Sorry, that's a little messy. And that's 22. So to finish this off, divide each side by 2. That would tell me that x equals 11. Now, just like these others, we got one value for x. That makes it a conditional equation. As long as it meets the condition that x equals 11, I will have a true statement. I will have a solution for it. Now, if you look at the next equation, B, I notice there's a parenthesis on the right with a number in front of it. I'm going to need to use distributive property before I try to do anything else. So let's copy down the left side just as it appears. But the right side becomes 7 times 2x is 14x. 7 times negative 5 is minus 35. Now when I get ready to put these x terms together, I happen to notice it's 14x on each side. So if I subtract 14x, what happens is the x's cancel on both sides. And many times students get a little freaked out here and they aren't sure what that means. What it means is I am left with 10 on the left equals negative 35. Now you have to ask yourself, is this a true statement? Of course not. 10 does not equal negative 35. And if you get a false statement after your x terms disappear, that tells you that you have a contradiction. In other words, it does not matter what number you put in place of x, you will never get the left side to equal the right. That means there is no solution or empty set. Nothing will work for that. If it's a contradiction, then there is no solution to this equation. Now, the other possible thing that can happen we'll find in C. If I distribute on this left side, because I see negative 3 in front of a parenthesis, I will get negative 6x. Negative 3 times negative 1 is a plus 3, positive 3, plus 5x equals 3 minus x. Now, I do see some terms that I can combine on the left. The negative 6x plus 5x, if I put those together, that gives me a negative 1x. The 1 is understood. We don't have to write it. We can just write negative x. So I have negative x plus 3 equals 3 minus x. So to get the x terms together, I would need to add x to each side. But notice when I do that, they cancel on both sides, and I am left with 3 equals 3. Now, unlike the one above this problem, this one is a true statement. 3 does equal 3. And when that happens, you have an identity. In other words, the left side will always equal the right side. It doesn't matter what I choose to put in for x. I can use anything, and the left side will equal the right. That would mean that our solution is all real numbers, or you can write it with the symbol for the set of real numbers, which is a capital R, but the vertical line has double bars in the capital R. So those are the three types of equations that you can have when you're working with linear equations. It's summarized for us here in this box at the bottom. If we're solving a linear equation and we get a true statement such as 0 equals 0, in other words, there's no more x there, but I'm left with the same number on both the left and the right side, that is called an identity. We just looked at that in example C. So my solution set would be all real numbers. On number 2, if solving a linear equation leads to a single solution, such as x equals 3, then the equation is conditional. Its solution set consists of a value such as a single number. And on the last one, if the linear equation, the solution leads to a false statement, something like -3 equals 7, then the equation is a contradiction. And the solution set is the empty set, or no solution.